All right, hello everyone, and welcome to today's webinar on careers in space robotics. So, thank you everyone for joining in for this YouTube live, which was supposed to be a LinkedIn live, but due to some technical issues, we have now switched into YouTube. But that doesn't matter, right? If it's on LinkedIn or if it's on YouTube, because we have the experts with us. And so, I'd like to give a small, brief introduction about them. So, with me, I have first Miss Monica Ekal, who is a PhD candidate in Space Robotics Instituto Superior Tecnico. I believe my accent was terribly wrong, but uh, yeah,
No, it
okay,
was
but I
great.
think she Okay, it was great. So yeah, that is good. It was great, and well, she okay. Yeah, please write boom in the chat section if you all are excited for this current webinar. Okay, and so she has been a research fellow at the Institute for Systems and Robotics, and has also worked on the robot Astro B, which I believe our audience is familiar with. So well, you're excited, and along with Ms. Monica Ekal, we have Dr. Shreya Santra, who is currently and uh, currently a PhD graduate from Tohoku University and is currently the Director of Space Technology at Spaceonova. I believe that you all must be excited to know more, so stay tuned for this entire webinar. All right, so how about we, we start from the very beginning and let's go ahead with maybe maybe just a small introduction as to how or your journey in the space industry and why are you so passionate about space. So maybe Miss Monica would like to go first.
Sure. So I made a couple of slides and I can start with them. Well, as Sautek mentioned, I'm a PhD student at the Institute for Systems and Robotics at the University of Lisbon in Portugal. And a little bit about my journey to getting here is I started with my BTech, which was in University of Mumbai. I did electrical engineering, and that's when I realized that robotics is something that I wanted to do. So I went ahead and I did a master's degree in robotics and control from École Centrale de Nantes in France. And after that, I did a research internship at EPFL in Switzerland, where I worked a little bit on control of drones. So that was already a little bit in the domain of aerial vehicles. So I went ahead and took the next step and working on space robots, which is what I'm doing right now, which is my PhD in something called dynamic uncertainty reduction for on-orbit free flyer operations. I can explain a little bit about this later today, and just about how I was, let's say, inspired or how space was something that caught on. It was mostly when I was reading books, and that moment for me was when I realized that okay, the Earth is but a tiny part in this universe, and there's so much out there. There's so much to explore, and there are robots that can do that, and there are humans that can go out there, but it's a massive challenge. So that's what really drives me, and every day that's what keeps me doing this. Yeah.
Yes, and well, all the challenges and everything, that is something we will discuss in this particular webinar, but not right now. We'll discuss everything. So I'm also looking forward to, getting to know more from you. So let's now move on to Dr. Shreya Chatra. So yeah, so a small brief introduction about your journey in the space industry and your why are you so passionate about space? Well, we all are, but yeah, so
Yeah, thank you, Satek. Thank you, Spaceonova, for giving this platform to talk about why I'm so passionate about space and my journey until now. So basically, I started from a small town called Dhanbad in Jharkhand in India, and I did my BTech in electrical and electronics engineering at NIT Jamshedpur. And during that time, during my undergrad, I had nothing related to space in my curriculum. So, but I always knew that I wanted to do something in this field. So I just continued learning by myself, taking online courses, reaching out to people in this field. And of course, back then and 10 years ago, there was not a lot of resources you could find because yeah, internet wasn't really that popular. And in the small town of Jamshedpur. So, yeah, it was very difficult. But then somehow I found about this yeah, Indian Institute of Astrophysics in Bangalore, which was offering an internship. And that's when I went there for an internship. It was a 2 months internship, but I really formed many contacts. I got to know people are actually passionate about space and astronomy and space engineering and stuff. So from there, I got to know that people were studying at International Space University in France, which was a full space in university. They would only teach about space. So I was like, okay, this is the place I should be in, and I applied for that and I got a scholarship. So I moved to Strasbourg in 2014-15, and there I actually met people who were thinking about like me, who were thinking about making space more sustainable, making space more accessible to everyone. And I got really inspired. I formed a very good network, and I kind of, and then things started happening. I got to know about many universities that were giving space dedicated studies. So I applied for the Skoltech in Russia, and there I did many projects related to space. And also, like, we launched stratospheric balloons, worked on different satellite missions, and also my thesis was on drones as well, just like Monica's, but it was more for warehouse management using drones and ground robots. And then on, I went on to do my PhD in space robotics at Tohoku University in Japan as a mixed scholar. And during my PhD, I also visited the German Aerospace Center at DLR in Munich, where I was working as a visiting researcher, and I was working on swarm robotic exploration. That was my main expertise. And after that, I graduated last year in 2021. And now I'm an assistant professor here at the Hoku University in the Department of Aerospace Engineering. And why I'm so passionate about, uh, yeah, basically, this is my, oh, sorry, this is my journey, like from Dhanbad and Jamshedpur, went on to um, France, Luxembourg, also Moscow, Russia, Germany. I also visited NASA JPL, and now currently in Tohoku University in Japan. And well, why I'm very passionate is like uh, I always followed Kalpana Chawla when I was very young. And basically uh, the Columbia disaster, that was the main triggering factor for me. And as I like watched the disaster happening on my TV screen, I wanted like, okay, this shouldn't happen. We need to make more like space more safe and for everyone, for humans, for any kind of and if Earthlings wants to go to some other um, planets, then it should be much safer. And that's how my passion grew. And more than passion, it became like a aim. And yeah, my parents and teachers were very encouraging about that. And I remember like when I was in the 10th, and we were just finishing school, we would write in the slam books, right, for the friends. That was like in our generation, so we would like on slam books. And I always wrote like I want to be a space scientist. And yeah, that was like 15 years ago. So yeah, that's how it happened. And I've been reading a lot of books and yeah, taking part in competitions related to space, even in school. So yeah, it stayed. I didn't give up on the way.
Okay, well, yes, Dr. Kalpana Chawla and Dr. APJ Abdul Kalam is an inspiration, not to you, but to many youngsters out there and for many people. Slam books, yeah, I think it was there in my time as well. So we are not that old, but I mean, yeah, so yeah, we are in the same generation, I believe. Okay, so all right, so one thing which most of our audience won't know is that Dr. Shreya Shatra and Miss Monica are already acquainted before. Okay, so they know each other. So I want to know that how do you guys meet each other? I mean, what were the odds of meeting each other, and how did you exactly go ahead?
Yeah, I mean, I can take that. So we were both working on related fields, and I think at the time, Dr. Shreya was in DLR, and so yeah, I think we just connected on LinkedIn because we were both interested to find out what the other was doing, and that's we've been in touch since then.
Yeah, the truth is we haven't met in person, uh, and it was mostly our passion for space robotics that we connected, and now we are together on this platform. And yeah, we keep in touch and share what we are working on. And yeah, I'm very excited to have Monica for also the space robotics training program that we are launching through Spaceonova. Yeah, thank you.
All right. So, well, that was a small and a cute interaction or a cute meeting. What has happened? And okay, and seriously, I mean, you guys haven't met each other. Okay, maybe post COVID, that is something which is there in your bucket list or a to-do list, which is there that you need to meet each other,
Yeah,
maybe somewhere in
definitely.
between. Okay. So,
Yeah,
well,
that's
one,
the that's the positives of your networking. So the space community is anyway small, but the space robotics community is even smaller. So yeah, it's a very niche field, and yeah, you need to make your contacts and form a network to know more about what's going on in this field.
definitely. And well, I can see that there are a few comments where I mean, you guys are being appreciated, and that is something which normally everyone wants to know is that what are your exactly, it's just like so Sai Pavan has already mentioned. So basically, what most of our audience wants to know is that can you just tell us about what are your current research activities and what applications of it you wish to serve in the future? Basically, what are you currently doing and what are the future aspects? It's something which most of our audience wants to know, including me as well. So, right. So maybe Dr. Shreya Chandra, would you like to go?
Okay.
Okay,
Yeah.
sure.
Uh, so yeah, currently I'm in the Space Robotics Lab in the Department of Aerospace Engineering in Tohoku University, and it's directed by a very famous scientist in this field, Dr. Kazuo Yoshida. And our lab is working on very diverse kind of robots. And maybe audience here might know about the Google Lunar X Prize and the Hakuto rover, which was developed in our lab. Unfortunately, it was not able to launch, but it was like it spinned off this company called iSpace, which is right currently in Tokyo, and they are launching rovers in this year or in the next few years. So yeah, it was a spin-off from my lab, and we are working on different other topics like terra mechanics, which is like like the interaction between rover wheels and soil for different planetary surfaces. We are working on limbed robots. We are working on orbital robotics, which are like used for debris capture, asteroid capture, and also. So this is like more general of what we are working on. And my work is mainly focused on swarm robotics exploration. So swarm robotics is basically like multiple robots working together to achieve a common goal. And it becomes very complicated when there are so many different agents. Like different agents mean different systems, so you need to have all the systems working and coordinating and communicating with each other. And I basically develop algorithms which would help these systems and these agents to communicate with each other and coordinate as they do the tasks that they are assigned to. And it also includes like slam navigation, uh, inertial navigation, radio communication, and also like, you know, so that they can basically know what they are doing. They can share the information, they can map, they can localize themselves in this unknown environment, and can finish a task in a much faster way. For example, we have our like the Perseverance rover, the
Mhm.
Curiosity rover on Mars, which are doing great coverage and great exploration, in my opinion. But then, as we advance, we will have to do these exploration in a much faster uh, rate, and also it will be much larger um, exploration area. So we need more than one rover, and once it increases the numbers, it becomes complicated. So this is my research, just like developing on the algorithms for swarm robotics exploration.
Well, firstly, very complex but very interesting.
Yeah.
Okay. It is indeed complex, but I was actually fascinated as to, I mean, multiple robots working together. I mean, just for same, it's so difficult to control a single robot. How you're going ahead and controlling 10 robots simultaneously, and 10 of them are not even doing the same job. Someone is doing something else, someone is doing something else, and then you have to go ahead and control it. Wow. That is indeed, again, as I said, difficult but interesting. Okay. And maybe Miss Monica, um, tell us something about your current research activities as well.
Sure. So I could start off a little bit about talking about free flyers. I'm sorry. And what are free flying robots? They are, you can say, basically spacecrafts that have manipulator arms on them to perform activities on orbit. And here you can see in on the top, you can see two examples of this happening, this in action. One of them is the Canadarm on the International Space Station. I'm sure most of you are familiar with it, and it's used more quite frequently to grasp incoming payload spacecraft onto the ISS and to grasp them and then to dock them with the ISS. The another, let's say, application of this would be to detumble or to repair or for maintenance of satellites that have stopped functioning. And this can also be done by using free flying manipulators. So they've been gaining a lot of interest for these kind of applications because right now, we are on the brink of talking about all these discussions about debris removal and making space sustainable. So for that, we do need to have a lot more automation in space and to focus more on reusing and to focus less on creating debris. So, talking about free flyers, there are also experimental platforms that are currently on the International Space Station. So, mostly they serve as test beds for people here on Earth to try their algorithms for for these future applications. So, one of them on the left is Astrobee, which is a NASA robot. It's currently there are two of them on the space station, and they are potentially going to be used for applications such as payload transportation or maintenance, inspection, and things like this. And then the second one is Simon. This is developed at DLR. And this one is more like a virtual AI, not a virtual, but a robotic AI assistant for the astronauts. So just to talk to them or to give them suggestions about repair work or just to keep them company, to be honest. And the third one are spheres. These were also developed at NASA, and they are They are no longer on the space station, but they were also used for testing some control and planning algorithms. So, as far as my work is concerned, I work on developing autonomy algorithms for free flying robots, and the overarching topic of my PhD thesis was uncertainty reduction, like I mentioned before. And why is this a problem? Is because if you're performing operations like docking or satellite maintenance or payload transportation or even on orbit assembly, then you have to grasp a satellite or a payload and then to take it somewhere. So when the satellite has grasped something, that means that its inertial properties, its mass changes, its inertia changes. So then the dynamics of the satellite change. And then this uncertainty, if it's not addressed, can cause a lot of safety issues and cause issues with precision in performing these tasks. And I mean, everybody knows that space is very expensive, and making mistakes there can cause us to lose a lot of money. So for this is something that I work on. I work on how to reduce this kind of uncertainty after a spacecraft has grasped an object. And what my work mainly consists of is developing a hypothesis. So thinking that okay, maybe we can use this technique for this purpose, and then to develop an algorithm for it, to write computer programs for that, and then finally to test it experimentally. And that's, I would say, that's also the most interesting, but also the most difficult part, is because it's very hard to find platforms to test your things on. And in this case, I was lucky to have to get NASA on board with this project that we were working on, and they were really interested and they wanted us to try our stuff on Astrobi robots. So that's how we got to test our work. Here on the top right, you can see I got to go to NASA Ames and then to test our algorithms. So by our, I mean this is a project in collaboration with MIT in Boston. And then this work we developed together, we tested it on the ground at NASA Ames. And then finally, in August and December last year, we were able to test our control and planning algorithms on the space station, which you can see in the bottom right.
I mean, that is has to be somewhere like, I don't know, this much, and the
Yeah,
amount of work is, yeah, this
yeah,
much.
it is. And I mean, there are a lot of things that you need to account for. And I learned this the hard way, that things might work in simulation, things might work in hardware on the ground, but things are going to go wrong in space. So that makes it even more difficult to really plan for everything. Yeah.
It is, I
Yeah.
mean, that is what makes it more challenging and interesting, right?
Yep, absolutely.
Yeah, and also Astrobi is a very good platform to test your algorithms before actually deploying it for actual satellites and in space, right? In the
Yeah.
microgravity orbit. So yeah, it's a very interesting free flyer.
So, I mean, as what I'm seeing is that you guys are doing so much work, so much of these activities along with, I mean, along with your studying and also developing and all these things. So, can you give, I mean, how does your day normally looks like, and some things about time management? Because yeah, that is something which is very much needed. So, how normally, what does your normal day looks like? Maybe, yeah, maybe Miss Monica would like to go.
Sure. So I'd say that I try to do most of the productive work or work that requires a lot of focus in the mornings. This is something that I've figured out over the years that works best for me. And then if it's working on research or thinking of ideas, tend to do that in the morning. And then in the evening, it's mostly, I mean, the afternoon, the post lunch time is mostly for coding or things that are are already planned out but just needed to be implemented. So that would usually be my day routine. And then uh, weekends and sometimes evenings could be for personal projects like this one. So that's usually how I go about.
Okay, and maybe something from your end as well, Dr. Shashantra.
Yeah, I actually have an illustration to show
Oh,
that.
Nice.
Yeah. So Basically, a lot of my time goes in reading scientific papers and knowing what's going on. So yeah, at least like the first half of the morning, reading papers when I have like clear mind and just knowing what's going on. And yeah, so, and then when I have experiments scheduled, I do on the experiments. uh, it's not every day, but yeah, maybe 2 or 3 days a week when it's scheduled. And yeah, almost every day, a lot of time goes in coding and troubleshooting all the algorithms, and also writing papers and journals, which is very important in this academic field. So we need to get our papers published to move forward in our careers. And yeah, now I also have coursework and teaching, and yeah, re- guiding the students. And during the weekends, I mostly travel or work on my hobbies. I have multiple hobbies other than the space, other than being passionate about space. And also, I work on many voluntary projects and STEM outreach and activities. And currently, also, I'm quite a lot involved with Spaceonova. So, yeah, I try to do that in the weekends.
Well, that looks like a very planned out day, and I'm pretty sure that out of the 25% of coding and troubleshooting, 99% is troubleshooting, 1% is coding, right?
That's true.
Okay,
Yeah.
and one more doubt. How did you get these numbers?
I just saw how many hours I spend in an hour, in a day. How many hours
Well,
I spend in a day. Yeah.
basically, you keep track of how much time do you actually dedicate to reading research papers, how much time does it go in experiments,
I
and that is how.
I keep a track, yeah, but I also plan the day before or something, so that I don't really, like, spend too much time just troubleshooting, or spend too much time on teaching. So yeah, I try to plan it out.
Okay, well, that is phenomenal. And okay, so well, that is what a normal typical day looks like. I mean, my day is also kind of similar, I think. But anyway, so I think I have got a few questions, and yes, people are asking a bit about, and mostly about, is that some career opportunities. What are the various career opportunities in the field of space robotics? And basically everyone is an undergraduate. Yes, I can see in the comment, mostly the undergraduates. And we don't mean normally we don't know what are the various paths that we are currently having, which is the what is the university to go ahead with, or what is the internship, maybe what is to go ahead with. That is something which majority of our audience is asking. And yeah, I'll just display the comment as well. There you go. So right, so how should a person go ahead with that, especially an undergraduate? Maybe Dr. Shreya Shatra?
Okay. Yeah. So can I
Yeah,
show a
yes,
slide?
please.
Okay. So, yeah, if you are in your undergrad, it's the perfect time to plan and get the skills that is needed for this field. So, yeah, you have, like, there's so many skills that you can develop, just like develop logic and systems thinking, judgment and decision making, because if you have to, program your robots, you should know how to make judgments by yourself. And also, doing like learning programming languages. Mostly Python is very popular now, and C++, MATLAB, and a lot of space robots are also working on ROS. So ROS is a very interesting topic to learn. And yeah, if you are planning to apply for universities for your higher studies, for masters or PhD, you can go to this link where I have, so you can just scan this QR code or use the short URL. And I have listed many labs, research institutes which have space robots or extreme environment robots as in their program, so you can check out. And also, if you are trying to apply for different companies, here's a list of companies. This is not all, of course, there are many more companies that are there, and these are a few which are really doing like developing interesting space robots. And yeah, that's it. And yeah, basically, like, there's a lot of things happening in the space sector, and this is the right time to get into this field and plan your future, or like, as we say, path planning. So you can plan your path in this field, because there's a lot of business happening, both private and in the government level, also in this Asia Pacific region. So, just a statistic to show how the space robotics market will evolve. And yeah, just grab this opportunity, increase your network, and yeah, stay in the loop. You can join many courses, you can build your network by like, all the space organizations. You can join these and do different projects, and also stay updated, basically.
Right.
Yeah.
So I think we are, I mean, as we have crossed this path, so I'd like to ask a related thing and your related opinion. So, what is your opinion on the future of private space robotics companies? As we are on that topic itself, what is your opinion about that?
Yeah, so I think private space robotics companies are really doing quite interesting work. And yeah, so as you can see, like iSpace, as I said, it's already launching rovers. Gitai already has a space manipulator on board the ISS, and so they are doing quite phenomenal work along with the space agencies. It's not just that the private companies are working by their own. And like, it's a perfect place to, you like, they are like, what, recruiting quite a lot of talents, because space agencies are very restricted to, like, the government projects, or what the government might be interested in, the current government might be interested in. So in that case, like, private space companies are much more free to explore, to get into the field that they want to, and to solve many challenges. Yeah. And yeah, as we have seen in other sectors like rockets and satellites, it was mainly the involvement of the private companies that actually brought the innovation. And the same would happen for space robotics as well, I believe.
Yeah, hoping for that day to come soon. And yeah, we are already on the same path. So, Miss Monica, we'll loop back to the previous discussion on the career opportunities as well, and then we can move ahead with your opinions about the private companies and what is their future.
Yeah, sure. So, if I mean, for all the undergrad students who are out there, I'd say that make sure you're aware that space robotics is a very diverse field. So consider one project, consider a Mars rover. You need a variety of people with a variety of skill sets to work on it. So let's say hardware, you need a mechanical engineer, you need a test engineer, you need somebody to simulate this thing. Then if you want to think of software, then there is planning, navigation, there is communications, there is architecture. So there are a lot of diverse fields. So for the undergrad students, or for anybody actually wanting to do space robotics, I would recommend trying to find something that you are you feel strongly about, that you like to contribute towards. And then I strongly agree with what Shreya said, was to go to LinkedIn, because that's really where you can find how the opportunities evolve, because opportunities in space robotics are going to increase for sure, given that we are going further and further in our exploration. and it's common knowledge that robots are going to be the first ones to be there to explore, let's say, the surface of Mars or surface of Saturn or whatever, and then to set things up for astronauts if at that point they go there. So there is for sure going to be an increase of opportunities, but just to keep in mind that it requires a diverse skill set, and then to try to explore a little bit and see which is the one that is of most interest to you, and then to go to LinkedIn and see how the job opportunities evolve and what kind of skills people look for. That would be my advice.
Okay. Well, thank you so much. And also, any comments on what is the maybe the future of space robotics, space companies? Any comments on that?
Yeah, I am really encouraged by seeing the number of space robotics companies worldwide, and also I see that there is this rise of interest for doing that in India, and especially with the increase of, or not even increase, with allowing private entities in the space sector in India. I think it's amazing, and yeah, I mean, I feel strongly positively about that, and I hope to see more companies and more people among those who are listening right here to come up with ideas and to come up with companies that can boost Indian representation in space robotics as well.
Okay, that would be, I think, phenomenal. And yes,
Yeah, I would
many
like to
companies.
add in that, uh, along with the Indian representation, I would also like to see more of women representation in this field.
Absolutely.
Yeah, and here you can see like two women talking about space robotics. So yeah, it's a very very interesting field, and we really need diverse disciplines as well as diverse thinking, and so that's very important that we have women and other people from also minor communities to get into this field, and so that you can have different perspectives for solving problems. So yeah, I believe like private sectors are more open for this, and uh, we'll see a very good diversity and community building up in the next few years.
Definitely. And
Yeah,
collaborations
I would
always
also like
open
to,
paths.
yes.
Right. Yes, please go ahead.
Yeah, sorry, I just thought of something, but based on what Shreya just said, was that it's true that if you think of space agencies, then they are more limited by the funding that they get or by the project that they have to do. But the private sector has allows a lot more exploration, and that's where, to think about it, that's where all the big ideas come from. So yeah, I agree with that.
And yes, collaborations does open a lot of paths, a lot of options for everyone. So that is something everyone wants to do. All right. So maybe at this point we would like to ask a few questions. I mean, we like to take up a few questions from the audience. So it's the Q&A time, guys. So we'll pick up a few questions from the audience, and let's see that what all questions do we have in the comment section. Okay, I can see a huge question. Okay, so Sai Pavan is asking that I don't have the best grades and no papers published yet. What should I do to improve my profile? Okay, so Pavan, to improve your profile, well, Spaceonova is launching India's first ever space robotics training program, which you should definitely enroll in. And that on the link for that is there you go, spaceonova.com/SR. SR stands for Space Robotics. You can go ahead and register for the training program where you would see that we have got we have got world class mentors who will be mentoring you throughout the training program. It's a 1 month long training program. More information, there you go on the link. And I believe that that would definitely help you in building your profile. Okay, so that was Pavan's question. So let's see what more do we have in the comment section. Hey, Satvik, how did you meet them? Okay, how did I meet them? Well, I met um actually met Dr. Shreya Shatra first. That was I think through Shivam only. we met, Shivam being the CEO and founder of Spaceonova. And I think how they two met is that another story. But I think I met Dr. Shreya Chantra through Shivam only, and I met Miss Monica through Dr. Shreya Chantra only. Okay, so well, that is how we met. That is your answer. And let's see what all questions do we have. Okay, so we have a question by Shahid Ilhan. Uh, Please forgive me if I'm pronouncing your name wrong. So, does Europe have regulations like yeah, ITAR in the US? Do engines require a security clearance to work, or just visa is enough? So, maybe Dr. Shashantra would like to answer this particular
Okay.
question.
Well, there's no specific ITAR in the Europe, but they do have restrictions on citizenship, such as like the European Space Agency only recruits European, like the ESA member state citizens. But of course, you can work on other projects which doesn't have this regulation, and there are many. For example, I myself have worked at the German Aerospace Center as a researcher, and only the visa was enough, and of course, the project proposal was good. And if you do a master's or a PhD in Europe, it increases your chances of working with one of these research institutes. And yeah, there are some restrictions, but also in the US, you can work with NASA, Ames, or many other space companies with, and you don't have to be a US citizen. So it mainly depends on your passion and the research project that you want to work on. There is always a way, I believe. Maybe Monica can add to this.
Yeah, I agree. It really depends. And for ESA recruitments, yes, they are really specific about wanting only European member states. And at the same time, there are some projects, even ESA projects, that hire companies to do a part of that project for them. Let's say to develop, I don't know, an arm, let's say, and then they would give out contracts to companies to develop that arm and to develop its software. And then sometimes these companies are open to hiring non-Europeans, and
Okay.
that's something that you can. I mean, you would be working for a company, but you'd still be working on an ESA project. So that is, I'd say that is a way to try to get into an actual space mission. And at the same time, if there are research projects, I think it is it should absolutely be possible for non-Europeans to get in on that. But yeah, the real ESA space missions might be a problem. But at the same time, there are always ways to 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 get a foot in the door. And for that, I would say networking definitely helps.
Yeah. Can I get back to one of the questions before this? How to improve the profile? So I would also suggest take participate in different competitions. There are many open competitions that are happening every year. NASA has competitions. Even like Space Nova will have the Space Science Challenges where you can participate, and you can work on projects which are related to space robotics, and then you can post it in your CV. So yeah, that
And
all would
as
help.
Dr. Yes, and as Dr. Shashantra mentioned about the Space Science Challenge, well, that is something which you are looking forward in the May of this year, and the link is there. You go, ssc.spacenova.com. SSC stands for Space Science Challenge, where currently the website is under renovation, but I believe just bookmark it and maybe see tomorrow or day after tomorrow, the registrations and everything will be open back again. That is something which you are mark or maybe create an event on your calendar. It's starting from May 2022, and there you go. More competitions, more platforms for you to go ahead and improve. So Saifa Zian is asking, how is the Japanese academic setting to work as a female researcher? I have heard it's a bit difficult for girls to survive there. I believe that the question is directed towards Dr. Shreya Shatra only. So I think
Well,
you
I
can go ahead.
survived. It's I wouldn't say it's very difficult. It's as usual for females all over the world, I would say. Usually you are the single one or maybe one of the two in the research table discussing about stuff. So it's not very difficult. Yeah, Japan itself has a negative impression about work culture because Japanese people work a lot, but the academic life is much better. And yeah, we have quite a lot of freedom working on the projects that we are working. And if it's involved with the companies like iSpace or JAXA, or if we are working with DLR, yeah, there is a lot of work to do, but we have a very international kind of environment. And yeah, it's you can survive if you're passionate about the work that you're doing. That's
Well, all right, that was something. And okay, so Nashid is asking, could you please explain what the systems engineering role in a space robotics project would look like? hmm So maybe feel free to jump in on this question.
Sure, I could go ahead and get started. So, I'd say systems engineering essentially for would would be for the whole mission. If you're talking about if you're talking about it, and then there would be uh, teams of people from with different, let's say, expertise. So there would be a team that works on navigation or GNC, and then there would be a team that works on the science, which is getting collecting samples, for instance. And then I would, in my uh, the idea that I have is that they would have to kind of interact with each other and think about what requirements the other needs and then how to meet them. So I haven't worked a lot in systems engineering, but this is the idea that I have is a bunch of people with different expertise working together, thinking about how the whole mission would pan out, but at the same time how to meet each other's requirements, because then they might keep changing throughout the mission. So then you have to have this door of communication open, saying, okay, maybe this arm can move just this much. So how much can GNC allow in this mobility problem, or things like that?
Okay, well, I believe that you have got your answer, Mr. Nashid. So, well, Tanmay is asking a question that are there any open undergraduate projects which he can apply for?
okay. So our lab does take in interns, but mostly in the graduate level. If you go to the link or the university's link that I have shared, there is the link to my university, and you can check it. But mostly the requirement is graduate level or masters or PhD students. So yeah, no open positions right now.
Okay, all right. Okay, so thank you so much for answering that question, Dr. Shreya. And Jay is asking, when do you see on-orbit servicing happening to commercial satellites? Maybe Miss
I can,
Monica?
yeah, I can
Yeah.
take that. So, Jay, I don't know if you're aware, but there are a lot of private companies who are already doing this. And there have been a few demonstration missions. One of them was the Japanese satellite ETS-7. Maybe Shreya knows about it. And then there they demonstrated. So they had a spacecraft with an arm, and then they demonstrated a bit of how this would look like. At the same time, I agree that it's a little nascent at this point. But for instance, there is a company called Orbit Fab in the US that's trying to do on-orbit refueling, and they have sent one satellite with the fuel tanks up there, and then there's going to be a second satellite soon, and then they're going to do demonstrations. So I would say that this is slowly, gradually becoming a reality, and there are a lot of companies that have their eyes set on it. So they are doing demonstration missions or getting started to develop equipment for that. So I would say just check online, and there are many of them who are working on this. And at the same time, like on the subject of on-orbit servicing, I think being sustainable in space, like I mentioned previously, is also something that a lot of people are doing. So, like you see, the SpaceX rocket is a the Falcon 9 is a big example that they want to have reusable rocket boosters. So, uh, yeah, so I would say that all of the space industry is moving gradually in that direction, and I think it's a good step, and we need more of that.
Okay, so I hope that that answered your question, Jay. Yeah, I hope that answered your question, Jay. And I think we have taken a lot of questions from the audience. And guys, if you have, or if you have missed any questions to take up at the end, or you can go ahead and write down in the chat in case you want to ask us anything. So as we are moving a bit towards the end of this particular webinar, I like to ask a question, or there's something which I wanted to ask is that what are the major challenges? As we have already mentioned that in the very beginning, there were a few challenges and a few hurdles. So that is something which even most of our audience wants to know. What are the various challenges or hurdles which came across, and how did you tackle them? So
Okay,
yeah, maybe yeah, you want to
I
share
can
something? Please
I
go ahead.
can go ahead. Well, the basic challenge that I had to face was that people were not aware of the field that I wanted to pursue. Uh, of course, it was not space robotics from the beginning, but I wanted to pursue anything related to space. But people did not really know much, and there was not a lot of courses that were offered to get into this sector. And yeah, like when I was planning to not sit for campus placements in my university and go for space related studies, there was a lot of, like, why are you opting for this where there is no future or it's so uncertain. So that was a major challenge. uh, Other than that, also, yeah, like lack of mentorship and guidance during the initial years of my journey. That was a challenge as well. And so, like, now whenever I uh, have time, I try to mentor students who are actually passionate in this field. And yeah, that basically that was the main challenge. And other than that, yeah, of course, like technical challenges are there every day, which I'm trying to solve my robots. But yeah, those are easy to solve.
Okay, well, I mean, yeah, challenges are everywhere, and I think Miss Monica also faced a few of her challenges as well, I believe.
Yeah, I'd say that it was a similar situation for me in the sense that I was doing electrical engineering, and in the heart of hearts, I knew I wanted to do something about space, but it took a while to get here. So I thought that maybe robotics was the way to go, and then that's why I got into that. And the space thing worked out for me because of I kept looking for opportunities, but at the same time, if it wouldn't have happened, I'd say that I would be happy doing robotics as well because I'm really interested in it. But when I was in my master's degree studying robotics and then trying to find something related to space, related to my skill set, was, I would say, that was the major challenge till now for my career. And otherwise, it's been good. There have been problems in the sense that I don't come from a research background, but then learning how to do research and writing papers. So that's also something that I guess everybody who does a PhD or a master's with a thesis goes through. So yeah, there are some things that come up, but yeah, you improvise on the way, and that's how it works out.
Okay, well, yes, that was pretty inspiring for me and for the audience as well. And yes, there are challenges, but we need to tackle them. And there are some bookworms in our audience section, and a few of them like to binge watch certain series or movies. So, do you have any book recommendations or movie recommendations which inspires you most to pursue your dreams? Maybe Dr. Jayashantra, any book
Okay.
or movie recommendations?
One of the most inspiring movie for me is October Sky. It's a, yeah, 1999 movie, and it's about a bunch of um, kids who want to launch rockets, and then when they grow up, they get into the NASA, the first rocket program. So yeah, that's one of the most inspiring movies for me, October Sky. And book, yeah, I read a lot of like biographies. So Dr. Kalam's biography, Wings of Fire, is one of the very motivating books for me, because he says about his journey and how he came across all the hardships and still like did his studies, and then, you know, president of India. So yeah, he has been a very inspiring model for me. So the Wings of Fire as well as Ignited Minds both were very inspiring.
Okay, well, those are some books and movies which I have written it down. And yeah, I need to watch the movie, especially. I haven't seen that. And anything from your end, Miss Monica? Any movies or books?
Yeah, I would also definitely recommend Wings of Fire. At the same time, I also read this biography. No, yeah, it's kind of a biography of Chris Hadfield, who it's called, I believe, An Astronaut's Guide to Life on Earth, which I found also to be very cool and inspiring. And I'd say inspiring mostly because he's very honest about the challenges of being an astronaut. So he talks about his journey where he wanted to become an astronaut, and he's Canadian,
Uh,
but Canada didn't have a an human spaceflight program at that time. But he decided on it, and then he kept doing things that would make him one, and then things worked out for him. So I think that that's something that's always stayed with me, um, to to be fully aware that it's going to be hard, but at the same time, if you like something, you one thing doesn't work out, something else does. So I really like the way that he's honest about all the challenges, even after becoming an astronaut during the training and commanding. So he was the commander, and then he talks about all the things. So I would definitely recommend that book as well.
okay, that is
Currently,
something to add.
yeah, currently I'm reading The Diary of an Apprentice Astronaut by Samantha Cristoforati, the Italian astronaut, and it's a very interesting book as well. I've just started, but it's already like captivating of how
Oh,
she
nice.
describes her experiences. So yeah, check out that as well.
Okay, well, I think well, yeah, I think my cart would be full of all these books today. That is what I'm going to do after the end of this webinar. And before we actually wrap up, there's something which I would like to ask from my end, and I think a few from the audience as well. And that is, yeah, there's one question, and that is whenever you sit and whenever you start to coding, um, the normal tendency is to get errors, right? The normal flow is to get errors. So when you encounter such an error and that error happens repeatedly over a course of time and that still does not solve, how do you actually tackle that specific problem, that specific module, which whatever we are working with? How do you actually specifically target that and maybe overcome, or maybe how do you solve that particular error, because that is something which bugs me a lot personally if an error is left unresolved. Maybe Miss Monica, you like to go ahead with that?
Yeah, I think there's no right way to do this. I guess it's like you said, errors are normal. They happen all the time. The key is to not get discouraged, I think, and Mm, what I would normally do is try to Google it and find a solution, or otherwise just approach, if it's really, if you're really stuck on it for a long time, then approach somebody who can help you.
Uh-huh.
But I'd say not, yeah, to not be discouraged right off the bat if you get errors. But at the same time, I don't think there is a way to do it. I yeah, especially for writing code such as C++, it's not reader friendly in that sense. So
Uh-huh.
you really have to trace back where the error might come from. So yeah, if I had to just narrow it down, I'd say don't be discouraged and don't. Uh, it's completely normal. Yeah.
Okay,
Yeah.
and
I
so
would
along with
like,
the yes, yes, please go ahead.
I would like to act like, um, not just coding, but also I get quite a lot of errors on electronics. So sometimes it's a very simple mistake, or maybe I haven't, you know, switched on the power amplifier or something like that. So, and then it doesn't work. And yeah, so just go back to the basics and check from what's from the starting, like if you followed all the procedures, and if you actually included all the header files and everything. So yeah, that's something to look into. And of course, sharing it with people who you're working with, or even in the open forums, that also helps quite a lot. Just discussing, you might get some ideas that you didn't think about before. So yeah, those are some ways I follow.
So basically, if you error it, Google it. That is how, or that was what Miss Monica said. If, and anytime you an error, Google it, or the communities are always there, because that's not only you who had the same error. Someone must have encountered exactly the same error which you have seen right now. And one more thing I'd like to ask Miss Monica is that, what was your reaction when your code ran for the first time on Astro B, and when it was successful, what was your reaction, or what was your feeling? What was your emotions when you're seeing that yes, it ran successfully?
Um, I would say relief was one, because there was all this intense stress building up to the point, mostly because then once you know that your payload is going to the ISS, you have to be in the loop with the scientists from NASA, and then you have to keep giving them updates every week saying, oh, I worked on this, but this might be an error. And for us, what was the big challenge was that we had some external libraries which we had to incorporate with the Astro B software stack, and that errors. We were just talking about errors. That was really hard because it wouldn't accept it, and then we had to find workarounds and things like that. So it was just a build up of all of this, and then finally when it ran, it was amazing. Like I feel like I mean, like if there was one highlight of my life, that would be it. Yeah.
A moment to cherish forever. Yes, indeed. Okay, so well, we have already moved on to the final part, or the final end of this particular webinar. So before we actually wrap up, could you please comment on the mindset a person should have to pursue such careers, or any last advice which you have for our audience to go ahead and pursue space robotics? Maybe we can start with this, Monica.
Well, one, it was. I'll be honest. I mean, getting to work in space is hard. It's hard, not in the sense of the work that you do, but in the sense of finding opportunities. So the mindset that I would say is, because at the same time there is hope, like I mentioned, that there is there there will be definitely an increase in opportunities in India, abroad, and even in space robotics in general. So what I would say is to keep the basics strong, and well, Spaceonova has a program for that. So I would say get ready or be ready with whatever basics related to the field you want to do. Maybe it's you want to work on robotic software, so then be ready with C++ or Python or whatever. And then when the opportunity shows itself, then you have already all the ammunition ready to present yourself as a suitable candidate. So my advice would be that yes, it's hard, but there is hope, and be sure to be on top of the game, like be on LinkedIn, see what people are looking for, and even if you're no longer an undergraduate student, maybe you have a lot of experience working on software, let's say, and then see what kind of software they use in space projects and how your skills can translate into that. So that's yeah, that's what I would say to um, to keep checking at what the industry wants, and at the same time to be on top of all the basics that we need for what you actually want to do. And yeah, I mean, I just want to quote here what I mentioned, this An Astronaut's Guide to Life on Earth, this book, and what Chris Hadfield says at the end is that if you don't find exactly what you wanted to do, you would be in a career that suits you and a profession doing something that you believe in. So I'd say there's no better words to sum it up than that.
Well, thank you so much. And any comments from your end as well, Dr. Shreya?
Yeah, I would like agree everything what Monica said, and along with that, try with the basics. Also, try to develop diverse skill sets, which was already mentioned before. So yeah, learn many different things, and that gives you a kind of systems engineering perspective how everything can work together. And yes, build a network, reach out to people in this field, and yeah, frame your questions well of what you want to do and why you want to do. And yeah, there will be people who will help you out with what you want to, yeah, do in this field.
And here we can see a nice little collage. Okay, that is SpaceX. Okay, yeah. And that is a lab right behind you in the first picture?
That's
Or
the NASA JPL
uh
Mars yard, where you have the twin of Curiosity rover. So that's the Curiosity rover twin. So basically, when you want to test some algorithms on
yeah.
Curiosity rover, you first test it on this rover on
Oh,
Earth.
cool.
Yeah, and then you send the code only after it's been debugged and fixed. So yeah, you can't take chances with space robots, right? So you can't go there and fix the robot. So yeah, this is the twin of Mars rover.
Oh, actually, I wanted also to ask then if they have some sort of a test bed that looks like the Martian surface. Is that
Yeah, yeah, it's
oh,
a
okay?
Mars yard. It's called Mars yard. So
Yeah,
they have a terrain which is similar to the Mars surface.
cool. It's very awesome that you got to visit and see what they have on the inside. Very nice.
Yeah. So yeah, I participated in the Caltech Space Challenge in 2019. So that's another challenge which you can also look out for. It happens every 2 years, and so they there you spend like 5 or 6 days working on a space mission, a space robotic mission, and you get to visit NASA JPL and talk to people who are actually like building these cool robots and how they are designing the mission and everything. So yeah, that was very cool experience there. Yeah, and then there you see the picture of JPL, and in Los Angeles, we also visited the SpaceX facility.
Okay, well, those are some really cool pictures. And yeah, I mean, that really inspires us to go ahead and do something great so that we can also go ahead and go visit all these awesome places. And all
Or
right, so I
create your
believe,
own.
yeah, definitely, definitely. So, well, we have almost reached the end of this today's webinar, and yes, time for again a little bit about Q&A, where people have mentioned a little bit about the questions. So Amrit is saying, in between training program we'll have NSIM. So what should I do in that time? We cannot do assignments that you would get. Okay, Amrit. So that is something which you don't need to worry about, because all the sessions and everything would be recorded and would be sent to you. And along with that, we also have pre-recorded videos which we would be sending you as well. And yes, and the number of, or what do we say, the sessions are not continuous. Rather, we have 1 or 2 days in between as a break, so you can go ahead and you can catch up in those times that is given for you to go ahead and practice all those things. So you don't need to worry about anything about your missing out on your instance or missing out on this training program. We have developed this entire training program such that it will not hamper with you. And in case any what do we say, in case you need any suggestions or in case you need any help, well, we are always open to help you out. And for the people who have tuned in late, the training program, yes, that is India's first ever space robotics training program, is Spaceonova is bringing with world class mentors, which you can go ahead and look out at www.spacenova.com/sr. So that is the link where you can go ahead and register for the same. And once you register, you'll get an email containing all the information about all the information and everything about the training program. And yeah, that is all about the training program. And the schedule, everything you will receive on the mail itself. You don't need to worry about, everything will be given on the mail. And yeah, so I think, do we have any more questions in the chat section? No, I don't think we do have any more questions. And yes, you can register for more details at www.spaceonova.com/sr. So I believe that brings us to the end of this particular webinar. So everyone, stay tuned and let's create a space ecosystem where limit tends to infinity. Thank you so much, Monica. Thank you so much, Dr. Shreya, for taking out our time for this webinar. And thank you so much to our lovely audience for staying and for asking so many wonderful questions in the chat section for us. So thank you, everyone, and stay safe. Till then, bye bye. Take care. Good night.